Today we will see stack data structure. Stack is an abstract data type. It is collection of entities that are maintained in sequence with two main principles. Addition of elements will be on top of most recently added item and removal of most recently added item from the same end. The end used to add and remove the elements is called as top. You can imagine stack data structure like this: stack of plates. If you want to add new plates, we usually place that on top. If we want to remove, we will remove from the same end top. See here, one is already in stack, two can be added on top of this one. Similarly, 3, 4, 5 and 6 also. Only top element can be removed first. So remove this 6 first, then remove 5, 4, 3, 2 respectively. The operation of adding an element to stack is known as push, and the operation of removing an element from the stack is known as pop. Push and pop operations occur only at one end, referred to as top. Last element added to the stack will be the first one to be removed. The operations of stack makes it last in first out data structure. Stack can be used at many applications. Some of them are expression evaluation, checking for balanced parentheses in an expression, and stacks can also be used in reverse Polish notation, converting postfix notations into infix notation and reverse also, and can also be used in undo function implementation in software to maintain list of operations for an undo function where most recent operation is the first one to be undone. Stacks are also used in recursive subroutine calls where state of each function call is stored in stack frame and placed on stack, and are also used in backtracking. Stack can be easily implemented either through an array or linked list. In either of these implementation, we need to implement push and pop operations. Array can be used to implement bounded stack. Bounded stack means stack is limited to fixed number of items. The program must keep track of most recently added item of the stack. To keep track most recently added item, variable top will be used. Let's see stack implementation with array. Stack is an abstract data type, holds collection of elements with two main principles: add elements on top of recently added item and need to remove most recently added element from collection. While implementing stack, we need to implement two main operations, push and pop. Push operation is used to add elements into top of the stack. Pop operation will remove recently added item from the stack. Here I am taking an array, named it as S, which will hold the elements of the stack. Here I am taking the array of size 10, and top is a variable which will hold the index of recently inserted item. Initially it will be -1, which indicates stack empty, means nothing is there within the stack. If I want to push an element into stack, first we need to increment this top. Suppose we need to perform this push operation and we are passing 5 as argument. We need to increment this top. Previously it was -1. Now after increment it will be 0. So first we need to increment the top while implementing this push function and add the element at the top location. So here second step, we need to add that element on the top location. Now this 5 will be added to the stack at the top index 0. Same thing will be repeated for next push operation. Top will be incremented to 1, then add this item 6 on this top index. Let's assume we perform this push operation also. These are the stack contents after 3 push operations, and now top is at index 2. Suppose if we perform 10 push operations like this, then top would be at index 9, and we want to perform one more push operation, then top should be incremented. After increment, top would be 10, but there is no index 10 in our array. If we try to access index 10 in our array, we will get error. So we need to avoid that push operation. To avoid that, we will write this if block if top greater than or equal to max -1. We should not try to insert that element into array. We should raise this error stack overflow. So in array implementation, the push operation increments the top index and adds an element in the top index after checking for overflow condition. If you want to get top element of stack, we need to perform pop operation. If stack is not empty, then pop should return recently added item, means it should return element at top. Then we need to decrement the top because we are removing one element from stack. Here we no need to delete that element. While printing the stack, we will start from this index 0 and we will go up to top. So even if you have contents at this location, we do not bother about that. Suppose if we perform one more pop operation, element at top index. Previously top was 8, so element 2 will be returned and top would be decremented. So now top will point to index 7. Suppose if you perform 10 pop operations on this stack, this last pop operation will return element at index 0, then top would be decremented. So now top would be -1. Again, if you try to perform one more pop operation, we should raise error. Since stack is already empty, top is at index -1. So we need to add this if block. If top less than 0, we should raise error stack underflow. So in array implementation of stack, pop operation decrements the top index after checking for underflow condition and returns the item that was previously at the top one. So previous top is stored in element x, that x will be returned after decrementing this top. This is the complete program for implementation of stack with array. We took the array of size 10. Initially top is -1. Push operation. First we need to increment the top, then place the element at this location. Pop operation will return element at the top, then top will be decremented. This is the code for printing the stack contents from index 0 to we need to go up to top. If we execute this program, this would be our output. See here, we are pushing 5, 6 and 7. After that 3 push operations, these are the stack contents. Then we performed one pop operation. So pop operation will return the element at the top. Last element is 7. So 7 will be written. 7 is popped out of stack. After popping this 7, we'll have 5 and 6 within the stack. After that, if we perform this push operation, then stack contents will be 5, 6 and 8. This is our output.